Hi, and welcome to the Hitech Farmer, the best show for young people wanting to learn about modern agriculture. In this episode, I'll be interviewing Max, who is the founder of Skytree, a company that provides DDAC technologies, that stands for a Decentralized Direct Air Capture, as for carbon capture. A few months ago, his company deployed the first unit into the vertical farm of Growie. With the sustainable source of CO2, they can now grow their crops more efficiently. And now onto the show. So hi, could you briefly introduce yourself and Skytree?
Yeah, sure. Hi, Sebastian. I'm Max. I'm the founder of Skytree. I'm British by nationality, and I studied physics and technical subjects in school and university before joining the European Space Agency in Holland. In Holland, I was working on a CO2 scrubbing process to keep astronauts alive inside, essentially a floating tin can in space. And this process was highly effective at removing the CO2 that astronauts exhaled. So my original partner and I thought, hey, well, if we have such an effective process here at removing CO2, why don't we apply this to the atmosphere? Because that's a good thing. Because we need that to fight climate change. And so I founded Skytree about 10 years ago from the European Space Agency, who funded us to do that. I now am a product advisor for Skytree. We brought on a CEO about 6 months ago, Rob van Straten, who is now sort of leading the company and leveling it up. We grew to a certain extent. We had 15 people. He's now expanding this so that we can really reach our true potential, and it's been great so far. So, yeah, and I like to scuba dive.
Okay, that's very nice. And what's the meaning of the name Skytree?
Well, our original name was actually Giora.
Okay.
Yeah, exactly. What does that mean? And it was like a combination of two ancient Greek words. So we figured that people generally wouldn't be able to spell it or really understand in any way what it was referring to quickly. So we went to a branding agency and they helped develop a new name for us. And essentially we came to Skytree because, well, we do what a tree does. We remove CO2 from the air in that way. But we're techie and we're engineering. So we added sky in front of it to give that impression. And that was
okay. And what carbon removal technologies are there currently, and how do they compare to each other?
There are a lot of technologies. First of all, you have to differentiate between engineering and biological means of removing CO2 from the air, right? So you can just for biological means, an example is just planting trees. And that's a great way to sequester CO2, right? We used to have 12 trillion trees on Earth. We're now down to about 4 trillion. We could probably up that to about 6 trillion with the amount of arable land and just open space there is on Earth. So that's 2 trillion trees with the potential to plant. That's a huge amount of carbon storage potential, right? So that's a great biological means of removing CO2 from the air. Another way, for example, is using certain types of rocks like olivine and grinding them down and then incorporating them into earth used in fields. And then over time, these rocks basically, they capture CO2 from the air and they turn it into limestone. They fix it into the rock, essentially. And that's a very simple process that takes no energy, that just requires this mineral that needs to be spread out in farmers' fields. Okay, so that's a great way. It's called rock weathering techniques. There are a number of other ways, including growing kelp in the sea to reduce CO2 from the air using biological means. On the engineering front, you have two main avenues of potential to remove CO2. The first is removing it from where it's emitted. So literally putting something on top of a chimney and basically scrubbing the CO2 out of the flue pipe before it actually reaches the atmosphere, and then taking the CO2 and doing something with it or putting it underground. and storing it. This technique has actually been around the longest, engineering-wise. This was developed already, I think, in the 80s. And there are a number of plants that are actually doing this actively, and millions of tons of CO2 is prevented from going into the atmosphere every year using this technique. And this has potential, for example, as we still can't move away from fossil fuel. You know, as you can see in Germany, they've reactivated over 60 coal-fired plants in the last few months because of the energy crisis. China is building a ton of new plants right now, as well as clean energy. So if we can complement that way of producing energy with capturing CO2 from the sources emitted, then this will be a way to basically prevent extra CO2 going into the air. And then the final way, which is the second manner, engineering-wise, to take CO2 out of the air, is something called direct air capture. And this is what Skytree is involved in. And the beauty of this is that it's not about preventing CO2 from going into the air in the first place. It's actually about drawing it back down, right? And so actually reducing the amount of CO2 in the air and then doing something with it or storing it. And that's great because that has essentially limitless potential if the technology becomes financially viable and we get enough backing, you know. Also, it opens up a ton of use cases for CO2, you know, for example, like the production of fuel, right? So something called synthetic fuel can be made from combining CO2 from the air and water, essentially to create methanol. And then that can be used to basically fuel planes or other elements of the transportation sector that can't run off battery power. And then ultimately, once we've really managed to scale this and get it working, we might be able to just draw a ton of CO2 out of the air and put it underground to actually reduce the amount of CO2 in the atmosphere itself to slow global warming. And so that's why I started Skytree, and that's what we do. We're a direct air capture company.
Yeah, that's very ambitious. And you use something called decentralized direct air capture.
That's true.
And why did you choose this method, and how does it compare to normal direct air capture?
Yeah. So essentially, what we're trying to do is introduce this technology in a financially viable manner, and have this technology working off market forces alone. So customers and the market actually wanting to use our tech because it adds value or it saves them money. And currently in the DAX sector, what you see is essentially, basically, there are very few plants that are actually operating at any meaningful scale. And those that are, for example, through Global Thermostat, Carbon Engineering, or Climeworks, are heavily subsidized either by private investment or grants. One of the reasons we think that this is the case is because they're targeting the large industrial scale CO2 market. Basically, either industrial CO2 for greenhouses or the sale of carbon credits. It's a very low price point, right? And it's hard to get the tech down to that price point to actually add value to the market right now. So with decentralized DAC, what we're able to do is target those markets with a much higher price point, such as vertical farming, and actually save them money and add convenience at the same time. And that's the principle of distributed direct air capture. And over time, as we roll out more and more of these units, the cumulative amount of CO2 saved will actually be pretty meaningful and maybe comparative even to centralized systems.
Okay. So do you use solid or liquid medium for the CO2 capture, and what's the difference between these two?
Yeah, most direct air capture companies use solid medium. We do as well. The only one that I know of that doesn't, in fact, is Carbon Engineering. They use what's called sodium hydroxide. Sodium hydroxide is great because it captures CO2 immediately on contact. And actually, it forms what's called calcium carbonate and limestone in that process. The disadvantage of it is that to re-release that CO2, the limestone has to be heated to over 900 degrees Celsius. which is very energy intensive and industrial. The solid solvent we use only has to be heated actually anywhere up from 60 degrees Celsius to release the CO2 again. So it's a much more benign and smaller scale process that's easier to implement. But it's slightly less effective at capturing CO2 from an airstream. So it doesn't get it all, but it doesn't really matter as long as we capture the amount we need.
Yeah. And so what's the price of, for example, 1 ton of CO2 produced by the Skytree solution and of 1 ton of the industrial CO2?
I'm not going to go into pricing right now because it's just a bit premature for us. But I can give you an example of how much industrial CO2 costs. And that is in North America and Europe, around 350 euros per ton. To give you a comparison, Climeworks is selling their carbon credits for over 1,500 euros per ton. So that's where commercial DAC is right now, even compared to industrial CO2.
And do you see, for example, your company competitive with these prices, in 10 years or so?
Oh, yeah. Well, I mean, a lot is possible in 10 years, so I'm not going to say no to that. This is engineering principle. And essentially, it's what we're aiming for.
Yeah. Why did you choose Growie to deploy the first on-site carbon capture unit?
Growie is based in Amsterdam too, where we are. And we actually had quite a nice, and we had a good connection with them through our network as well. So things just came together. And it happened. Then they happened to be one of the leading vertical farming companies in Holland, but also just around the corner from us. And they were very excited about our technology, and so it was a very smooth ramp-up process. And we're actually going to be kicking off a second pilot with them this year as well.
Oh, nice.
Yeah.
And what can Skytree do for the growers, or why should growers choose the Skytree solution instead of just buying the CO2?
Yeah. So ultimately vertical farming, I'm going to stick to vertical farming because this is where DDAC is directed towards, or at least, not industrial greenhouses just yet. And essentially in vertical farming, these farm owners and founders, right? And maybe this resonates with you as well. They're all about saving the world energy and resources, essentially, to provide the same amount of food. Okay. Also shortening supply chains and distance from source to where the food is consumed, and also reducing the amount of pesticides and chemicals that are used in the growing process. And that's all that vertical farming can do, which is exciting. Unfortunately, to do this, they need to burn fossil fuel or buy carbon positive CO2 to grow their plants effectively. That doesn't really mesh well with their story. And also, it can be pretty inconvenient and tough sometimes even to source industrial CO2 and compressed gas. You can imagine you're in the middle of a city and you have to get these cylinders shipped in and you have to install them. Or you're in Saudi Arabia, where you might not have industrial CO2 source nearby. So we come in and we say, look, guys, don't worry, we solve both those pains. Here's circular CO2. That's you scrub CO2 out of the air and in a very circular fashion. Sure, we have an energy footprint for that process, but if you power our units through renewable energy, then it will be completely clean. If not, then we will save you relatively this much CO2 per kilo you use. And secondly, here's a device that provides plug-and-play CO2 very simply and easily wherever you may need it. So you can just plug it in, switch it on, and our smart software also automatically regulates partial pressure inside the grow volume and actually pushes optimizations over time as we learn more from our systems and how to optimally grow plants. So it really levels up the supply of CO2 generally, as well as making it greener. And and I also forgot, will probably save you money too on the actual CO2 you buy.
Yeah, that's really convenient.
Yeah.
And did you do some research on how big is the impact of CO2 enrichment on the growth of the crops?
Yes, I mean, we're not experts. We're not like a vertical farming company, but we
Sure.
have heard and learned from the sector that yields can be increased from anywhere between 20 to 40% using additional CO2. So
Okay.
it's pretty significant.
Yeah. And does the CO2 increase have, for example, any impact on the pests in vertical farm or greenhouse?
I actually can't comment on that.
Okay.
Yeah.
And
I can say vertical farms generally suffer less from pests because it's such a closed environment. So they don't
that's
get
true.
in, so that's nice.
Yeah. And are there, for example, any downsides of the CO2 rich air for the growers, for example, that work in a CO2 enriched environment?
Nothing meaningful, Every day when you're indoors, you're probably exposed to higher CO2 levels anyway. So it's okay. And officially, I think CO2 only really becomes toxic where essentially you suffer the danger of, for example, fainting, from I think 20,000, 30,000 ppm, something like that.
Okay.
And we're operating at 1,200 in farms. So
yeah, which industries have the biggest consumption of CO2?
Yeah, I mean, cement uses a ridiculous amount of CO2 in its production process, but it's not really, it doesn't really consume it in that sense. It just more emits it in the process of production. But there is potential to use CO2 in the process of producing cement to actually make better cement while sequestering it as well. And that's a really interesting way to move forward for us as society. And Carbon Cure, for example, is a company that's doing that already. The fertilizer production also emits a lot of CO2, but in terms of actual processes that consume CO2 and require it, plastic is a big one. Beverage carbonation, so I think Coca-Cola, like pumping drinks full to make them fizzy. And industrial greenhouses use millions and millions of tons of CO2 every year to grow their crops.
And do you see yourself supplying your solution to these industries in like some time from now?
Our mission is to scale carbon removal technology and to improve the process because that's good for humanity. And we want to deploy it through our DDAC units. If one day those DDAC units will scale to meet the needs of these industrial processes, I think the potential is there. But right now, we're just focused on deploying our initial units and proving out the technology and getting revenue in from them. Are
there any, for example, government policies that support these carbon capture technologies?
Yeah, there are a lot. In fact, the Inflation Reduction Act, just signed by Biden, I think even yesterday, will allocate $3 to $4 billion for direct air capture. I'm not even kidding. $3 to $4 billion.
Solely to direct air capture.
Solely to direct air capture.
Holy.
I know, right? To establish centralized direct air capture hubs around the United States. It's crazy. And I think that's over the next 5 to 10 years. So that's going to be helpful. I think to date, the United States has allocated not more than 100 million to direct air capture. And I don't know of any other governments that have directly funded direct air capture, to be honest. We have brought in like clean tech grants and clean technology grants before from governments, which have been useful. But nothing that I know of, for example, in Europe, dedicated as it is in the US to solely scaling direct air capture.
Yeah. So what countries are leading the industry right now?
Yeah, I mean, I think really it's basically Europe and the US. There are more US companies doing it, especially the last few years. Tons have been funded. But Europe is the world leader in Climeworks, and we have a few other interesting companies doing it. And there is scope because Europe is very good at combining public and private money, that it would be a better environment to scale direct air capture in, because that might be what the sector needs, essentially. That combination for this important technology that it's still hard to really make commercially viable just yet.
What's the ultimate goal of Skytree?
Our ultimate goal is to improve the technology. That's where we're scaling direct air capture technology. And we are deploying our DDAC units and taking that approach to the market in order to do it. So building a revenue base through organic market pull, and then to essentially get to the next level where the technology becomes more and more commercially viable. And that's our mission, because we think it's important. That's what we're about. In fact, our company, we work with research institutions like MIT, University of Amsterdam, 3-4 universities that push new technology to us for testing. And we also work with some private partners that provide us samples, material samples, processing ideas that we then test and understand whether we can basically make them work for one of our product lines. So we're very much about harnessing what's out there and finding a way to best commercialize it so that we can make as much impact as possible.
And do you work, for example, with the Wageningen University?
We're not working with them necessarily like in a project right now, but I mean, we've certainly signed NDAs with them, and we certainly talk to them a lot.
Okay.
Very, very good knowledge hub for vertical farming. Maybe even the best in the world.
Yeah, I'm looking to go there after my bachelor.
You should do it. It's great. Yeah, you have to deal with Dutch weather, but apart from that, it'll be good.
And do you want to mention something we haven't talked about so far?
Yes, there would be one thing, which is we have an open call for pilots at the moment in vertical farming. So if you're a vertical farm and you're interested in making your CO2 circular, saving money, and having, let's say, a smarter supply mechanism for it, then please contact us. We're open to conversations.
Okay, that's all from my questions. Thank you very much for joining the call, for your time.
Yeah, you're welcome.